Okay, so welcome back. So now what we're going to do is we're going to solve, we're going to solve linear inequalities now. Okay, so what's an inequality? Well, we talked about inequalities before, so we know that it's going to be a set of numbers or a set of solutions. So solving inequalities, linear inequalities, is very similar to solving equations, except the difference is when you solve an equation, you get one answer. Okay, a linear equation will give you one answer. When you solve a linear inequality, you will have possibly an infinite number of answers. Okay, most cases you're going to have an infinite number because it's going to be a set of numbers. Okay, so let's do an example and I'll show you what I mean between the difference of the two solutions. Okay, so I've got two expressions, linear expressions set up. One is an equation. I've got the exact same thing set up, but instead of using an equal sign, I'm using an inequality. So I'm going to solve both of these and show you the difference in how we would show the solution. Okay, so let's get started. So we have this. So again, I'm going to subtract 2x from both sides. So that gets rid of that, and we get what? 2x plus 6 equals -2. So then I'm going to subtract 6 from both sides. And what do I get? I get 2x equals -8. And then I divide both sides by 2. And I get x equals what? -4. Okay, so this is my solution. My solution is one number. It's telling me that x, the solution is x is equal to -4. So it's telling me if I stick -4 back into here, I'm going to get a true statement. Okay, now let's solve this one and see what happens. Okay, so here I go. I'm going to do the same thing. I'm going to subtract 2x from both sides. I get 2x plus 6 is greater than -2. And so then I'm going to subtract 6 from both sides, right? So this and this. And so I get 2x equals -8. And then I'm going to divide, I'm going to divide both sides by 2. And I get x is greater than -8. Now, the difference is in this solution here, I'm sorry, not -8, -4. And so the only difference here is, in this case, I got one solution. Here, I've got an infinite number of solutions, okay? Here, if I was to graph this on the number line, right? So I've got 0, I've got right? And if I was to graph this on the number line, well, in this case, I've only got one point, right? That's it. That's my solution, graphed. But if I was to graph the solution over here, x is greater than -4, well, that's going to look a lot different. Okay, so in this case, it's greater than -4. So I'm not going to include -4. So I'm going to put a circle, right? An open circle, which tells me that, okay, I want everything except -4. So I do not want to include -4 in my solution set. So, and then I want everything that's greater than -4. Which way is greater than? To the right. So now I'm going to shade in everything to the right. So that's how I would graph my solution set. Okay? Or in other words, if I used set builder notation, you would say x I want the set of all values of x such that x is greater than -4. That's my solution. Okay? So again, big difference dealing with inequalities and equations between those two when you're talking about the solution. Okay, but you solve them very similarly. The only difference is you have an equal sign here. Here you use an inequality. Okay? The only warning that you have to watch out for, and I'm going to probably repeat this again, is the only thing you have to watch out for is when you multiply or divide both sides of an inequality by a negative number. Okay? You must flip the inequality. Okay? So let me repeat that. Anytime you multiply both sides of an inequality by a negative number, or you divide both sides of an inequality by a negative number, you must flip the inequality. As long as you remember that, then you can solve these just like you do pretty much with an equation. Okay, see you next time.